Hey guys, welcome to another level 2 calculus viewer question. This was sent to me earlier today in my Facebook page. So if you do have any questions, just send it there and when I get some time, I'll try and get around to answering them. Anyway, let's get started with this question. What we've got here is, this was actually part of a series of questions. I actually thought they were actually connected, but in reality they're not. This is just a circular play pool. That means if you think about what a circular play pool looks like, it's like a little cylinder like this. All right, and then we've got the height and the radius of this pool add to 2 meters. Okay, so that's something that's really important. You've got height plus the radius equals to 2 meters. So I'm going to write down h plus r equals to 2. Now it says use calculus to find the maximum volume of the second pool. Well, whatever happened to the first pool, don't worry about it. We're just calculating this particular pool. We got to justify why it's maximum, and the only other information that we're given is that volume of a cylinder is pi r squared h. Now when you are doing any of these questions with finding maximum area, maximum volume, or anything like that, what you can't have is you can't actually have two different variables. What I mean by variables is like two things that can change. All right, because if radius changes, then height also changes. Height changes in this question. So what we're going to do is we're going to rewrite h, but instead of h, we're going to write it as in terms of r. So real simple, we're going to put h is equal to 2 minus r. All right. And once we do that, what we can actually do is we can actually get rid of the h in the volume formula, because volume of a cylinder is pi r squared h. But because we actually proved that h is equal to 2 minus r, we're going to get rid of this h and we're going to replace it with pi r squared multiplied by 2 minus r. All right, now when you want to differentiate, remember, when you differentiate like this function here, you can differentiate with respect to r, or you can differentiate it with respect to h. So the thing is, if you're going to differentiate it with respect to r, you cannot have any other variable apart from r in your equation. And if you do dv over dh, you can't have any other variable apart from h. All right, so just to kind of give you another way of doing this, now in my original question I'm going to do dv dr. All right, so that's what I'm going to actually work out, dv dr. But before I do that, I need to actually expand this bracket here. So I'm going to expand it and I'm going to write that as 2 pi r squared, because that pi r squared times 2 is that, and then pi r squared minus times minus r is minus pi r cubed. So that's my volume function in terms of r. Now let me show you what happens if you actually do it with respect to h. What would then happen is that instead of putting h, you would actually have done r equals to 2 minus h. All right, and that means what we're going to end up with is v is equal to pi r squared h, and instead of r here, you're going to replace it with 2 minus h. And what ends up happening is you're going to get v is equal to pi 2 minus h squared multiplied by h. So you've got a little bit more work to do with dv dh, but you're still going to end up with this with the same answer, so it's not a problem. So what we're going to do is we're going to differentiate the volume function, which means we're actually going to do dv dr in this side. And when we do dv dr, we're going to get 2 comes in the front, so that's going to be 4 pi r minus 3 pi r squared. Now once we differentiate it, remember that max or minimum is when the gradient is equal to 0. So in this case, when dv dr equals to 0. So we're going to put down 0 is equal to 4 pi r minus 3 pi r squared. Now looking at it, we've got pi r as a common factor, so we can take it out and we're going to get 4 minus 3 r. So at this point, what we have actually set up is we've actually got 2 brackets that equal to 0. So it's kind of like the quadratic that we did. Well, it is a quadratic, so you got 2 brackets equal to 0, which means you've got pi r is equal to 0, or 4 minus 3r equals to 0. Now with pi r equals to 0, r is equal to 0. And then 4 minus 3r, you're going to get negative 3r is equal to negative 4. And then we're going to get r is equal to negative 4 divided by negative 3. So that means we've just discovered what radius is. Radius is equal to 4 over 3. So when it's 4 over 3, that's when the maximum volume is going to happen. Now there's something that we need to actually make a note of here. So we just have to say r can't equals to 0. Therefore r is equal to 4 over 3. Because if you think about it, if the radius is 0, that means you've actually got no cylinder. Okay, so once we figured this part out, what you can do is you can actually you still have to justify whether it is going to be the maximum or minimum. But what we are going to do is we're going to first work out, go back to the question and just have a look. What are we trying to figure out? Find the maximum volume. So we do have to find the maximum volume. We know that when r is equal to 4/3, that's when the maximum volume happens. We also know what the formula for the volume is with respect to r. So I don't really need to worry about height because I've already created this equation. Remember this equation right here? Because that's my volume equation, I can just use that. So that volume equation is now going to be, what is it going to be? What did I write? Pi r squared times 2 minus r, that's the one. So pi r squared times 2 minus r. And because 4 over 3 is when the radius is 4 over 3, that's when the maximum volume happens. I just need to substitute these two r's with 4 over 3. So I'm going to get volume is equal to 4 over 3 squared multiplied by 2 minus 4 over 3. So when I do this, I just need to get my calculator just to work out what my maximum area is. What I'm going to do is I'm going to put 4 over 3 as like this, and I'm going to store that as the answer. And then just makes it a bit more easier, that's why. So I'm going to go shift pi multiplied by 4 over 3 squared. So that's going to be answer squared multiplied by 2 minus answer, to do it in one shot. So what I've discovered is that the volume is equal to 3.72. Was it meter or centimeters? Let me just go back. I think it was meters. Oh yeah, 2 meters. So it's going to be 3.72 meter cubed. Now, we've got to try and actually prove that this is a maximum volume. So what I'm going to use is I'm going to use the second derivative rule. So we actually figured out that dV dr was equal to pi r. Oh no, we're going to leave it like that. I think it was 4 pi r minus, where was that? There we go, 4 pi r minus 3 pi r squared. All right, so we double differentiate this, which means we differentiate it one more time. We're going to get dr squared, that's just 4 pi minus, what have we got? 3 times 2 is 6 pi r. Okay, so what happens is at this point, you've got to substitute r as 4 over 3, because that's what we found out as maximum. So we're going to substitute r in here. And if this value ends up being a negative, then it will be a maximum. And if it ends up being a positive, then it'll be a minimum. So let's actually work it out. And we can see that it's going to be 4 pi minus 6 pi times 4 over 3. I'm not actually going to use a calculator for this. And the reason is because all we're really worried about is whether it's going to be negative or positive, right? So negative 6 over 3 is negative 2. So negative 2 times 4 is negative 8. So I'm going to get negative 8 pi. And then this is equal to negative 4 pi. And I can say here, because sometimes you might write it like this, v double dash is less than 0. Therefore, it is maximum volume. So you could write it like that as well. Okay, so hopefully this answered your question. And that's basically it for this video. So it's just a lot of little steps, but I think I'm running a tutorial in half an hour for this, similar to these types of questions, but not with double differentiation, but still these types of word questions. Anyway, guys, sorry for the long video, but that's basically it. As always, don't forget to like and share this video, folks, and also subscribe to keep up with the latest content. There should be some playlists popping up. Check them out, and thank you for watching.